This video is for topic 7.3, reaction quotient and equilibrium constant. The objective for this topic is to represent the reaction quotient for a reversible reaction and the corresponding equilibrium expressions. So we have our generic equilibrium reaction. A plus B produces C plus D. Little a and b and little c and little d are the coefficients. The capital letters represent the formulas for the compounds. Now, remember, we're looking at our rates of forward and our rates of reverse. And so we can treat these a little bit like elementary reactions, like we did when we talked about kinetics. And so we're going to see that our concentrations of each of our products and reactants are going to be raised to their stoichiometric coefficient. So that's going to be their power. We always do products divided by reactants. So we're always going to do the compounds as products divided by the compounds as reactants. Now, a reaction quotient is represented by the symbol Q, and that tells you that ratio of the forward and reverse reactions at a specific time. The equilibrium constant, symbolized by a capital letter K, represents the concentrations at equilibrium. It's still products divided by reactants. But Q is the ratio at a certain time. K is at equilibrium. Oftentimes we'll see them as Q sub C and K sub C, meaning for concentration. We can also look at pressure and partial pressures. So Q sub P and K sub P if we're dealing with gases and looking at pressures instead of concentrations. Neither of these expressions will include solids or liquids, so we're only including gases or aqueous solutions. Now, if Q is less than K, that means that we have not yet reached equilibrium, and the reaction is moving in the direction of reactants to products. If Q is the same as K, it means we're at equilibrium because the ratios are the same. They're calculated the same way. Q is just at a certain time. K is at equilibrium. So if that time is the same as at equilibrium, you know the reaction is at equilibrium. Now, if Q is greater than K, that means that our products is going to be greater than our reactants, which means that our reverse reaction is dominating. And so it's going from products back to reactants at that point in time. And so we can use Q and K to determine whether or not a reaction is at equilibrium. We're also going to use our expression for our equilibrium constant to both calculate the equilibrium constant and to calculate the concentrations at equilibrium. That's what we're going to look at next.